In order to understand closures in Python, we first need to understand what nested functions are. Here on my screen, I have defined a function called outer func, inside which we have defined another function called inner func. Both of these functions have a print statement, and then finally we are invoking the inner func function, which is defined in the outer func. Now let's try to run these methods and see what output do we receive. So let's try to run the first function, the outer function, which is called outer func. Now when we run outer func, we see that both the print statements are getting printed, the one for the outer func and the other one for the inner function, which basically means that inner functions can be defined and invoked from outer functions. Now let's try to run the second function, the inner function that we had defined inside the outer function. And voila, we get the name error, which indicates that scope of the inner function, inner func, is restricted to the inner scope of the outer function. So this inner function that we had defined here is not within the global reach. That is why we cannot invoke the inner function from the outside of the outer func. So far we were invoking the function from the outer func. Now let's make a change in this function body and see what happens. So if I return this inner func from outer func and try running the code and then invoke the outer func, but since it's outer func is returning a function, let me assign this outer func call to a variable, because all functions are the first class objects in Python. So we can actually assign a variable here. So when I do closure equal to outer func and run this code, it just prints the inside outer function. It executes only this particular line of code, but it does not invoke the inner func. And instead it returns the inner function directly to where it is called, right? And this value is stored in the closure. And when we try to invoke the closure, now we get this inside inner function. The value returned from the outer func is actually the key to the concept of closures. And at this point, we can define what a closure is. A closure is a function defined inside another function, but then returned from that function. So here inner func is a closure as it's defined inside another function, outer func, but then it's also returned from the outer function. Closures find more significance when outer functions have some local variables, because the key property of closures is that they remember the state of the outer function when the closures are born. So in the outer function, currently we do not see any local variables defined. Hence, to understand it better, let's and check out the next example. On screen now is a function called getProduct, which contains a nested function multiply numbers, which prints the multiplication of x with the multiplier that is set as the argument of getProduct function. And then finally, the multiply numbers function is returned by the getProduct function, which is nothing but the outer function. right? So since we are returning an inner function called multiply numbers, which is defined in the outer function, multiply numbers becomes the closure. Okay. To invoke the closure, let's call the outer function get product and assign this to a variable called double, which is nothing but the closure name. And since get product also expects a argument, let's pass on to over here. Okay. So this is basically the first closure that we are defining using the outer function get product. Okay, let's try to run this closure. But before that, we have to invoke it. So let's invoke the closure double. Sorry, I haven't invoked the first outer function. So now this is invoked. Then rerunning the second piece of code. So as you can see, get product is executed and we see this print statement inside outer function, and then we finally see the output of the closure after calling the closure. So this way we have defined our first closure. Now let us also define a couple of more closures. You got me right that multiple closures can be defined using the same outer function. So let me define our next closure, which is triple. Another one quadruple. Okay, so we have defined three closures, and if we try invoking each of them, so in the output we see that all of the closures have executed themselves. However, they have maintained the state of the outer function. So if we analyze the output returned by the first closure, that is double, we see it prints two times the value of 30, right? So it remembered that the passed on parameter was set to 2. Similarly, when we invoked triple, it remembered that at the time of creating triple, the input passed was 3. Hence, it multiplied 30 with 3 and gave us the output as 90, right? Similarly, at the time of generating the closure quadruple, we had passed in the argument as 4. So it multiplied 4 by 30 and yielded the result of 120. So multiple closures can be created using the same outer function by passing different parameters to that outer function, which essentially enables the different closures to have different copies of the inner scope of that outer function. Now, after having invoked the multiple closures that we created, let us check if these closures do remember the state of the outer function. So that we can test by deleting the outer function on which these closures were created. So let me call the delete operation on the get product. So we will write delete get product, right? And now if I access get product and try to run this, I get a name error as expected because get product does not exist anymore. We have deleted the get product, right? And now if we invoke the same set of closures that we tested previously, we still find the closures giving the same output as they were giving when outer function was existing, right? So this is an example to show how each closure remembers the state of the outer function when that closure was born and therefore is not affected by the deletion of outer functions. So this is a key feature of closures, and let's try to validate it with yet another example. On screen now is an outer function called create book list, which accepts an input parameter called genre, and inside it has a local variable called book list which is set to empty, and then we are defining a closure which is in this case add book, because add book finds its definition inside the outer function, as well as we are returning the add book function from the outer function. So this function acts like a closure, and add book accepts the book name as the input parameter, and it appends that book name to the book list and finally prints the updated book list, right? So this is what is happening inside this create book list outer function. Now as a next step, we need to invoke create book list and assign this function call to a closure. In this case, we have named the closure as fiction books. In order to invoke this closure, we have to pass in a parameter, right? So let's try to run this closure, and we see there is a list that gets printed containing the book name that we had just passed while invoking the closure. Okay, let's also try to add another book name to the same closure, and try to run this code again. So we see that the second book actually got added to the book list that was instantiated when we had first created this closure, right? So as we saw earlier that the closures remember the state of the outer function when they are born or when they are created first, right? So this book list stays active and it remembers that the last entry in the book list was The Hobbit, and therefore the second book name got added or got appended in the same book list, right? Now, let's try creating another closure, okay, and name this closure as thriller books. And we'll do the same. We'll invoke the outer function and we'll pass on the thriller attribute to set the book genre. And we will probably pass this book name as Gone Girl. Okay, and try to run this piece of code, and we see that this time when a new closure was created, the book names got added to an entirely different book list, Okay, different than what we were using for fiction books. Now let's try to add one more fiction book here and see whether the closure still remembers the state of the function when it was in called first. Okay, so fiction books. This closure keeps the state of the outer function intact, and therefore, when we add another book name to the fiction book's closure, it remembers the state of the outer function that was existing that time, and it uses that state and adds the new book in that local variable. So basically over here, this book list, as a local variable is remembered by the closure, and therefore the closure can very well identify which data needs to be added where. Now let's try to delete the outer function to check if state of the outer function is still held by the individual closures. So I will write a code to delete the outer function. So we'll say delete create book list and we'll execute this. And when we invoke this, we see that it still works. Okay. So this demo clearly validates the key feature of closures, that closures do remember the inner scope of the outer functions, and one closure can work independently of another closure. So guys, with this we wrap up this video on closures in Python. Hope you found the tutorial useful. If you like the video, make sure to like and subscribe to the channel. See you in my next video.